Have you ever really thought about what happens in that tiny split second after you hit send on an email or click on a link? I mean, your data goes on this wild, invisible journey across the entire planet. Today, we're going to pull back that curtain and trace that incredible trip. And the first question we got to ask is,
When that little piece of data, we call it a packet, leaves the safety of your computer, where does it actually go? It doesn't just, teleport to its destination. It has to navigate the massive, tangled web of the internet. So think of it like a quest, and every single packet is its own digital adventure.
Now, to really understand this quest, we're going to use a really simple analogy: a road trip. Seriously, thinking about how you drive from one city to another is probably the best way to get your head around how the internet routes trillions of packets every single second.
Just imagine you're driving from, say, Mogadishu to Kismayo. There's not just one straight road, right? You're going to hit intersections, you'll have to make choices, you'd use a map, you'd look at road signs to pick the fastest or the best path. Well, the internet works in an almost identical way. It's just a giant network of digital roads.
and the comparisons are kind of perfect. Those intersections on our road trip, on the internet, those are routers. The map you're using to figure out where to go, that's a routing table. And that road sign telling you exactly which turn to take next, in the world of networking, we call that the next hop.
Okay, so let's leave the road trip analogy for a second and look at the actual tech. We're going to zoom right in on that digital intersection, the router, and its super important map, the routing table. This is where all the big decisions are made.
So a router is basically just a special purpose computer. Its one and only job is to be a traffic cup. It sits at a crossroads on the network. It looks at the destination address on every packet that flies by, and it makes one simple but absolutely critical decision. Where do I send this thing next?
And how does it make that call? It uses its rulebook, the routing table. But here is the secret, the really cool part. A router doesn't have a map of the entire internet. I mean, that would be impossible. It just has a local guide that says, hey, if you want to get to that part of town, you need to go in this direction.
And this little rulebook has 3 key pieces of info. First, the destination network. That's where the packet is ultimately trying to get to. Second, the next hop. Now this is important. It's not the final destination, it's just the address of the very next router in the chain. And third, something called a metric, which is basically a score that tells the router how good a path is based on things like speed or how many routers it has to jump through.
Here's a super simple example of what one of these tables looks like. So, if a packet trying to reach Google comes along, the router looks at its table and goes, okay, for Google, I need to send it to this router right here. Same thing for Facebook. But what about that last entry, the one with all the zeros? That is where the system gets really, really smart.
It's almost as if the router is thinking to itself, I've never heard of this place, but I know a bigger, more important guy who probably has. And this simple idea is the key to something we call the default route.
This is basically the router's safety net. It's the what if I'm lost instruction. If it gets a packet and has no idea where to send it based on its table, instead of just throwing it away, it sends it along its default route. This route almost always points to a much bigger, more powerful router at your internet service provider. It's the when in doubt, pass it up the chain rule.
Okay, so we have all the pieces of the puzzle now. We've got our routers, our routing tables, and our next hops. So let's put it all together and follow one single packet on its epic journey from your computer all the way to a Google server.
So, it all starts at home. Your computer sends a packet to your home router. That little box has no idea how to get to Google specifically, so it just does what it's told. It sends the packet to its default route, your internet service provider. Now the huge routers at the ISP take over. They have these massive tables, and they find the best path forward. From there, the packet hops, and it hops again, and again, bouncing between routers all across the internet, with each one making its own tiny, independent decision. Finally, it arrives at Google's network. And the most amazing part? This entire trip, spanning continents, built on millions of tiny choices, happens in literally the blink of an eye.
But this brings up a pretty big question, doesn't it? How do all these routers get the information to build their tables in the first place? I mean, does some person have to go and program every single one by hand?
Thankfully, no. They do it automatically, by talking to each other. They use these special languages called routing protocols. You might have heard of some of them, like OSPF or BGP. These protocols let routers constantly gossip with each other, sharing updates about the best and newest paths across the internet.
A fantastic way to think about it is like a team of surveyors mapping out a city. When one of them discovers a new shortcut
or finds out a road is closed, they immediately tell all the other surveyors. Just like that, everyone updates their maps at the same time. This is what makes the internet so incredibly resilient and able to adapt to changes in real time.
So this entire amazing invisible system is working around the clock. But you know what the best part is? It's not actually invisible. You can see it for yourself, right now, from your own computer.
So, let's do a quick recap. We learned that routing is all about choosing the best path. Routers use their routing tables to point to the next hop. The default route is their safety net for unknown places, and they build these tables by talking to each other using protocols. Now let's go see it in action. There's a tool built into pretty much every computer out there called Traceroute. All you have to do is open up a command line or a terminal window and type one of these commands to see the exact path your data takes to get to any website you want.
What this command does is pretty cool. It sends out a little test packet and then reports back every single router, every hop that it passes through on its way to the destination. You'll see a whole list of IP addresses, which are those digital intersections your data just zipped through. The entire journey is laid out right there for you to see.
So go on, give it a try. Run a Traceroute to your favorite website. You might be shocked to see your data travel halfway around the planet and back in just a fraction of a second. Which leaves us with one last thought. Now that you can actually see the path, what can you learn from your data's journey?